So this is a set of notes on measuring and constructing segments. So the first thing we need to do is define what a segment is. So typically if I'm going to name a segment, I may name it with a bar over top and call this like segment AC. So essentially what a segment is it's a set of points. So I'm going to have 2 points, A and C, and the segment is all of the points that are in between those 2 points. So this would be segment AC. We call the point A and the point C the end points of the segment. So they have a special name. We call them endpoints. So the next thing we need to do is start applying numbers to this. Okay, so the way we go about applying numbers to a segment is through a thing called the ruler postulate. So a postulate in and of itself is a statement that doesn't require proof. It's something that, like, when you look at it, should be fairly obvious. Okay, so what the ruler postulate says is that if I have a line, something that's going on forever, I can take all the points in this line and I compare them with the real numbers. Okay, so I can make it so that each point on this line lines up with a particular real number. And the way I do this is I put down the point and I call one of the points 0, and I pick another point and I call that point 1. And that's all I need. I need a 0 and a 1. Once I have that, I know where all the other real numbers are. Like, let's say I want to find 2. Well, from 0 to 1, that's 1. And then, if I go a little bit further, hey, look at that. If I go one more of those units away, I get 2. Another one of those units away gets 3. This one is going to be 2.5 or 5 halves. Back here is 1/2. Okay, so that's all the positive real numbers, right? If I were to extend this a little bit more and put 4 out here, I could go, ooh, guess what? That's pi, because that's like 3.1. So that's not even just like positive integers or positive rational numbers, but I have the irrationals, right? I also have the transcendental numbers like pi. So all the real numbers on this side are positive. And, well, if I know where 1 is, I know where -1 is. -1 is going to be over here. -2, so forth and so on. So this is like -1/2. So I have a way, according to this postulate, by establishing where 0 is and where 1 is on the line. Once I know where that initial unit is, I know where all the other numbers have to be. So once I have this coordinate system, okay, so let's think about this again. I have the coordinate system. I know where the 0 is. I know where the 1 is. I can find the distance between any 2 points. Okay, so let's say I have a point out here, and we're going to just put that at x. And I have a point over here, and it's at y. And what the ruler postulate says is that if I take the absolute value of those 2 coordinates, I get the distance between those 2 points. Or another way of saying this is I get the length of the segment that connects them. So this is also the length of that segment. Now note, it doesn't matter if I put them in the wrong order, because if I take the absolute value and I have the numbers in the wrong order, I still get the same number, because taking the absolute value, this is going to be positive or negative, this is going to be the opposite sign, but the absolute value gets rid of those signs and makes it all positive. Distance is always positive. It's always going to be greater than 0. So this is how we kind of get into how to take measurements on segments and how to measure distances, is using this ruler postulate. Okay, so we're going to introduce a little bit more now that we know how to measure. We're going to introduce a thing that's called the segment addition postulate. Okay, so the segment addition postulate is, again, it's a postulate, so I don't have to prove this. It's pretty straightforward. So the basic drawing here is, again, I have a segment. We're going to call it segment AC. And I'm going to pick some point B, which is between A and C. So B is on this segment. Okay, B doesn't have to be in the middle, it's just got to be somewhere on the segment. Then the following statement is true. So note, let's get something straight here. If I have segment AC, its length, the length of that segment is just AC, no bar. Bar is an object. This is a segment. No bar is a number. It's its length. So we can say that the length from A to B plus the length from B to C is equal to the length from A to C. So this is what we mean by the segment addition postulate. And you're going, no kidding. That's something, but that's why it's a postulate. We have a name for this concept, but we don't have to prove it because it's pretty obvious that if I add this piece to this piece, then I get the whole thing. Okay, so that's what that postulate says. Okay, I also now have a way to define congruent segments. So congruent is a type of equivalence. We use this symbol with a tilde and an equal sign. So I want to be able to say, how do I know when segment AB is congruent to segment CD? So I have two segments, and I want to have some semblance of equivalence. So all I mean by this is that the length of AB is equal to the length of CD, and I would find that length using our ruler postulate. So if I have two segments that are equal length, I call them congruent segments. Okay, so the last thing I want to go after today is what's called a midpoint of a segment. So what is a midpoint? Okay, so let's say I now have, again, some segment, and let's call this one PR. I have a segment PR. Now, if I want the midpoint is going to be some point, I'm going to call it M. It doesn't always have to be M, but in this case, I'm just going to call it M, so that the length of PM is equal to the length of MR. Or in other words, segment PM is congruent to segment MR. If I have that this segment and this segment are congruent, that they have the same length, then M is the midpoint. So this is the midpoint of segment PR. Alright, so let's kind of do a little summary of what we've said today. Okay, so let's summarize our ideas. The first one is we have a definition of a segment, and a segment is a point and another point and all the points in between them. So let's call this segment AD. That's going to be the point, another point, and all the points in between them. We get measurement by using the ruler postulate. And that's just saying, if I know where the 0 is, and I know where the 1 is, I know where everything else is, and that the distance between two things is the absolute value of the difference of their coordinates. Okay, so that's the second big idea. We have a segment addition postulate. Which basically says that if I add up the two parts, I get the whole. No surprise there. I have a definition of congruent segments, which just means that they have the same length. And the midpoint is something that breaks a segment into two congruent parts. Alright, so there you go. Make sure you capture the information here, and we'll move on.